Good to go. Okay, thanks everyone for joining. My name is Mark Donsky, and I'm a Director of Product Management at Cloudera. I focus on our data management and governance solutions. I'm here with Chung Shea, and Chung Shea is a lead architect on our data management solutions as well. Chung joined Cloudera in the past year through our acquisition of DataPad, where he was a co-founder. So I'm very pleased and honored to be presenting with him. I hope this will be a helpful presentation for all of you. Just to give you a little bit of background on what to expect, I'm going to start with a little bit of an overview of basically the state of trust and visibility inside Hadoop and what makes it particularly challenging. And then I'll go into the kind of what trust and visibility really means for a typical Hadoop deployment that spans all the way from maybe a retail sector or to a highly regulated government intelligence kind of sector. And then after that, I'll boil that down to specific capabilities we're looking for inside a typical Hadoop distribution. From there, I'll hand you over to Chung, who will talk about how you can address these various trust and visibility issues using basically capabilities that are in every Hadoop distribution. Okay, so he'll go through in a lot of detail that should help you see how you can already take advantage of this regardless of what you're using, which Hadoop distribution you're using. And then after that, I'll give you an overview of what makes Cloudera Enterprise unique, specifically in this area. Okay, so, and we'll certainly have some time for questions. Okay, so if we think about Hadoop, I think probably the best way to look at trust and visibility and then look at Hadoop is to look at kind of the history of Hadoop. First off, trust and visibility, I think we often think of as opposing forces. Either you trust your environment or people can see what's in it. But that's certainly not the case, or it doesn't have to be the case, where you have to choose one over the other. But when you start looking at a typical Hadoop distribution, what you'll see is that over the past few years, there's been a significant increase in the amount of data that's landing inside Hadoop. Certainly, we have customers with petabyte-scaled clusters, diversity of data, so not just structured data, but semi-structured and unstructured data, and then lots of users and lots of compute engines. Looking at that in a little bit more detail, a couple years ago, Hadoop would be quite frequently used as an active archive. So you would have structured data, you would bring it into the cluster, it would be available longer, you would potentially use Hive or some SQL tool to analyze the data, and it was cost effective, it made the data available longer, and so on. And also, the typical users who would access that data were really limited at an organization to data scientists who were really computer scientists who understood distributed computing concepts like MapReduce and understood how to code in either Java or Python. Now you fast forward to today, just a couple years later, what you see is that 80 to 90% of an organization's data assets are typically semi-structured or unstructured. And as a whole, I think we've heard at this conference several times, the amount of data that organizations are accumulating on a year-over-year basis is doubling. Now, the semi-structured and unstructured are particularly challenging for trust and visibility. If you have web logs, let's say you're a retail site, and you have web logs, customers can punch in credit card numbers, those credit card numbers can make their way into the web log can end up making its way into Hadoop. You can have a rogue user who writes a regular expression parser to extract the credit card numbers from there, and you have a security breach on your hands. And without the right controls in place, you won't even know that took place. Okay? So that's the case with unstructured data or semi-structured data. And when you're dealing with unstructured data, it's potentially even amplified. You could have customer call recordings, or you could have loan documents. Buried inside all of these files can be sensitive data. And as far as the government is concerned, as far as regulation is concerned, it really doesn't matter how insidious the data is. It's your job to protect it. Okay? So that's the case for data, or the complexity of data and the challenge with trust and visibility. On the user side, we have a number of customers at Cloudera who are targeting rolling out their enterprise data hub to hundreds, and in some cases thousands of concurrent users. That means you have a lot of people accessing the data hub, often in our case using Impala for interactive queries, using Tableau and other partner tools. So a lot of interactive analysis is taking place inside the data hub, and you just need one user, again, to extract sensitive data. And again, without the right controls in place, a security breach can take place. And then finally, I do want to make the point that security breaches is often seen as the worst case scenario with the absence of trust or visibility. But really, there are a lot of insidious issues that surface across the board, even if you don't have to worry about sensitive data being divulged. Trust and visibility really affect everyone. Okay, so I'm going to go through each of the different classes of users briefly and how the absence of the right controls and the right capabilities in your Hadoop distribution, or at least taking advantage of the capabilities that are already there, can affect all the various classes of users. First off, business users. I've spoken with around 200 of our customers over the past year at Cloudera and have found that even the most sophisticated of users in the most sophisticated of deployments, those business analysts often will rely on the data sets that they already know about. Okay, so you go to, if you're a sales analyst, you go to the quarterly sales feed that comes in once a quarter and you work with that. But if there's a new data set that's there, first you may not even know that it's there, and then if it is there, you don't know if it's complete, you don't know if it contains all the information you need, and even worse, if you do know that it's worthwhile, you may need to join it with other data sets and not know which data sets you want to work with. Okay, so business analysts have a lot of, I'd say that kind of boils down to trust. Trusting the data sets that they found and finding new data sets. The other thing I should point out is that often what happens is that as you roll out your data hub to more and more users, your Hadoop distribution to more and more users, if you're an administrator, you're going to be inundated with questions. Users will be asking you, what does this table mean, and where do you get this feed from, and what do I join it with? And even if the Hadoop deployment can scale, your bandwidth won't scale. So there needs to be some kind of mechanism for users to figure this stuff out reliably on their own. Now, the information security side of things, we've kind of discussed this already. This is all about governance, compliance, and risk management. Typically, if you're dealing with any kind of sensitive data, it's by law, whether it's PCI or HIPAA or NIST or whatever standard is relevant to your industry, you need to make sure you're protecting access to the data. And it's not just keeping track of who accessed things or what they tried to access, but it's also knowing what they did with it. If you have a sales transaction table and you have credit card numbers in there and you also have product codes and you have two users accessing that table, which one of the users took the credit card numbers out and which one took the product codes out? Then finally, there's the database administration side of things. This is a whole other level of making sure, the Hadoop administrators and the DBAs, they're in many respects burdened with the task of making sure that the Hadoop cluster is optimally performing, that they aren't wasting resources on additional hardware, that they aren't setting up replication factors that are unnecessary, or conversely, setting up replication factors that are necessary. These database administrators need to understand how to optimize the models as they're ingesting more and more data into the Hadoop cluster. That's critical to make sure that there's user adoption. So there are lots of, I would say that all of these different stakeholders care about trust and visibility from their own point of productivity. But now if we boiled all of this down to specific capabilities inside Hadoop, the final slide I'll show you before I hand you over to Chung are the five main categories, we would say, of, we can switch the conversation over to governance. Okay, so trust and visibility really boil down to governance inside Hadoop, knowing what people are doing, what they're doing with it, what exists there, and how it got there, and so on. So I'll go through each of these points pretty briefly. Audit logs. Okay, so Chung will make the case that auditing is scattered across the Hadoop file system, and it's very difficult to figure out what took place at the event of a security breach. But there are some capabilities inside Hadoop that can help, and he'll show you what you can do there. Auditing answers what a user accessed or tried to access. Lineage takes it a step further and answers questions like, what do they do with it? Lineage is also quite challenging in Hadoop, but that doesn't mean it's not regulated. If you print a number in a quarterly report, or if you conclude that a drug is safe to bring to market, or any kind of decision you make inside Hadoop that has significant implications, it's quite possible that either internal or external auditors will come in and say, explain to me how this took place. Then data policies is really the issue of stewardship and curation at scale. How can you make sure that as data comes in, that you're doing all these various activities in an efficient way? Even to the point when I said that administrators can't scale with the data, data policies really is the way of making sure that you can scale. And then finally, I intentionally put technical metadata and business metadata at the bottom because that's really the foundation of anything you want to do inside Hadoop from an efficiency perspective. Knowing what's inside your cluster, whether it's from a business context or technical context, like which files are older than 7 years, which files are older than 7 years that haven't been accessed in the past 5 months, or is there anything in the data hub that contains sensitive data with the wrong permissions? Do we have any sensitive data that's not encrypted? All these kinds of questions are answered only when you have a solid metadata foundation. Okay, so Chung is going to go into much more detail about all of this, but this is really the background And I hope this is helpful for you.
All right, thank you, Mark. Okay, so let's take a look at each of these building blocks in a little bit more detail. So metadata, why is it important? As Mark has been mentioning, metadata allows us to understand our data, and it also allows us to put context around our data. When we talk about metadata, we generally divide it into 3 different categories. The first, probably the most useful and the closest to the end user, is business metadata. This is generally high-level information that links your data to business terminology, taxonomy and ontology that's specific to your enterprise, specific to your team. Technical metadata, on the other hand, is things like the data model, your table schema, file formats, anything that allows us to actually access that data. And the third category is operational metadata. These are your information about actions performed on your data. So things like job status, start and end times, resource usage, so on and so forth. Putting all that metadata together allows us to answer some really important questions. If you wanted to ask who are the high-value customers to my enterprise, you have to define a lot of things. What does high value mean for your business? How do you define a customer? How do you link all that data together? Where is my customer data stored? So on and so forth. All of that you'll need to answer before you can answer the question that really matters for your business value, for your business. Right, so technical metadata is managed within each Hadoop component separately. So whether it's file system like in HDFS or database like in Hive or operational metadata in Pig or Yarn, each component has different types of technical metadata. And technical metadata allows you to answer questions like, show me all the files belonging to a particular user that was modified last week, or what are all the columns in this table. Not only do each component have different types of metadata, they also allow you to access it and manage it separately, whether it's through the command line, through a database interface, or through a REST API. In order to put all that technical metadata together, you need to learn all of the different APIs and all of the different services. Okay. We can't talk about technical metadata without specifically mentioning the Hive Metastore, because it's such an important component in the management of technical metadata. It stores all the information about your Hive databases, tables, views, and columns in a structured table and gives you access to it via database interface. And on top of that, there's a project called HCatalog, which is a management layer for the Metastore. On the one end, it abstracts away file locations and storage formats. And on the other end, it makes the information from the Metastore usable in Hadoop services other than just Hive. So you can use it. You can use it from Pig or MapReduce, and so on and so forth. Now, both Metastore and HCatalog are great efforts in managing technical metadata, but they're both incomplete, and the fundamental design is set in such a way that it's insufficient for the variety of data and formats and technical metadata within Hadoop. So business metadata is, as I said, is probably the most important kind of metadata for your data management system, right? And I think it was a Gartner analysis that said without proper governance with business metadata, your pristine data lake is nothing more than a stinky data cesspool. Right? And so these custom business metadata allows you to ask these questions like, find me all the files for a particular clinical trial, or find me all the data for a particular high-profile customer, or where's all my sensitive data. All of these things involve definitions that are not standard to Hadoop, that are specific to your business. Okay. In Hadoop, there is just no business metadata management system. There are limited ways where you can shoehorn some of that into extended attributes, right? But it's really putting a square peg in a round hole. So while metadata allows you to understand the state of your data, auditing allows you to understand the history of your data. Right? Hadoop Audit Logs are generally in this JSON format. In the slide, you can see samples from HDFS and Hive, but other services like Impala or HBase and other components all use a similar format. Right. Each of the services manage their logs separately, and the logs are rotated when they reach a certain size. Both the log location and that size limit when rotation happens is configurable. Right. So accessing the logs, by itself, it's already a little bit tedious. You have to figure out where that log is. You have to parse that log. You have to know when log rotation happens, so you can always be reading the right file. But that's not even the difficult part of the problem. The problem really is in all of the things that you built on top of your audit information. So Mark mentioned an example of, let's say you have a suspected data breach. In order to figure out what happened, you might have to consolidate audit logs from multiple services, right? And then it might be back in time, so you might have to look back in about three months to find the relevant audit log information. And then you have to filter it to limit it within the relevant time window during which you think that breach happened. And none of that is available in Hadoop, in the Hadoop components today. Moreover, Hadoop is generally just a part of an entire enterprise data management system. So whatever we built to allow the users to have access to audit logs and understand the auditing information has to play well with auditing tools and SIEM tools like security information and event management tools for the entire enterprise. So our RSA, for example. So we've talked about metadata and we've talked about lineage, or we've talked about auditing, right? But all of that is just collecting disparate pieces of data together. But really what we want to do is also to connect them together. We can answer questions like, if I wanted to delete this piece of data, what impact would it have? For certain industries, you have a regulatory requirement to maintain data lineage, to understand where that piece of data can come from, to track how data is being used, and to even have very fine-grained lineage tracking at the column level for things like structured tables. Right, so you can't do this. You can't do this in an automated fashion in Hadoop, although that lineage information is embedded in all the technical metadata. So a job configuration contains information about the inputs and outputs of that job. Right, the input might be a Hive table, and that Hive table in the metastore will tell you which HDFS directory is backing up that table. And for the queries themselves, we can parse them to figure out how each column in the input table is connected to the columns in the output table. And the last component here is policies. No matter how much information we have, information is of limited use unless we act upon it. And all this information that we've been collecting, the metadata, the lineage information, the audit information, it's a veritable treasure trove of actionable information, right? We can do things like archive data that hasn't been used for a while. We can auto-classify data so we can figure out, okay, here are my social security numbers, here are private information about my customers, and so on and so forth. And then once I've classified that information, I may want to automatically encrypt sensitive data. And finally, if I find permissions are too loose on especially sensitive data, I may want to fix that automatically and restrict access to those pieces of data. And while certain tools within Hadoop offers limited ways for you to define actions based on triggers, generally there's no sort of good general action framework that allows you to take care of the very important use cases altogether. Okay, so I'm going to turn it back over to Mark
Okay, thanks.
to summarize here.
Okay, thanks very much. So, certainly I think we've both made the case that A lot of these areas are available inside a core Hadoop distribution. Some of these areas, like lineage, for example, are effectively non-existent in business metadata. What I'd like to do briefly is shift over to Cloudera's distribution and show you, this has certainly been an area that we've been focused on for more than 2 years, and we feel that it's certainly an area that makes our distribution unique. So I'd like to give you a quick demo of what we offer here in this area. Okay, so I'll start off. Cloudera Navigator is part of Cloudera Enterprise, and Cloudera Enterprise is our enterprise-ready distribution of Hadoop. With Cloudera Navigator, it has all of the key areas of governance that we just spoke about: unified auditing, unified technical metadata, unified business metadata, policy management as its foundation. Okay, so everything is, actually, let's see. There we go. Okay, so so you can see that everything is listed here. We have unified auditing, metadata, search. What I'll do is start with auditing and show you an example of, let's say there was a security breach in the past couple of days and we want to figure out what took place. So we'll click on auditing, and certainly all the audit logs that Chung spoke about are the basis of what we bring in here. We make it bigger? Yeah, let me see if I can do that. Let's hope that's okay. We'll see how it works with displaying the zoom level. Okay, so all of the audit logs that Chung spoke about are the basis of what comes into Navigator, but effectively, we intercept all that audit information. So you don't have to worry about configuring the audit logs correctly. You don't have to worry about log file rotation. You don't have to worry about misconfiguration of the log files. As something is written or something takes place inside Hadoop, we automatically aggregate all that information into a single location. That's important for 2 reasons. The first reason is exactly what Chung was speaking about, a centralized view. You can look and see what took place from yesterday. Are there any denied accesses in the system, and figure out what that user did. Secondly, though, it's important because Hadoop is one piece of a much broader set of enterprise applications that most organizations have. And most organizations that care about security or trust or visibility or governance typically have broader enterprise tools, such as IBM Guardium or RSA Envision or Imperva SecureSphere, QRadar, and so on. And it's necessary for these systems to consume the auditing information that we provide. We certainly have integration with all of those, and we can talk about that later. But it is important that this simplifies the integration with these broader frameworks for the other groups in your organization. So over here, if I wanted to see something as simple as, let's say, any denied accesses, I just set up this environment in the past few days, but let's say in the past 30 days, are there any denied accesses? You can see all the different types of filtering that we do in the auditing. So if I want to see everything a user did, I can do that. If I wanted to see everything on a particular table, I can do that. I'm going to search on the allowed flag. Okay, so anytime a user tries to do something like write a file in HDFS when they don't have write permissions, allowed will be set to false, and that'll be an audited event. So I'll click apply here. We see a couple of denied accesses here. I'm going to go through this demo pretty quickly. If you're interested at our booth, we can go through it in more detail. I just want to give you a taste of one approach to solving this that's been used quite heavily by our customers. Okay, so we see this user named training tried to do a couple of things, like create a directory called stolen data. So not too bright with the file naming. But if we click the filter icon beside the username, we can then see what else this user has done. So I'll remove the denied access flag. And now I can see everything this user has done over the selected period of time across Impala. Actually, there's quite a bit of Impala here. We have one HDFS here. And we probably have some more HDFS. So a complete view of all the activity this user has done. And if I want to just see the queries that this user has run, I can restrict that or filter there. And now I can see all the queries this user has run on both Impala and Hive. And if I were to expand on a particular query, you can see we capture the actual columns that were accessed. Okay, so if you have 2 users at the time of a security breach, one of them they both access sales data. One of them pulls credit card numbers. The other one pulls product codes. You can figure out the difference here. We also redact any sensitive data so that Navigator itself isn't PCI subject to PCI constraints, so automatic redaction of credit card numbers, email addresses, and everything in the log files. A lot more to auditing, but what I'll do just for the sake of time is switch over to searching. Metadata, okay? So this is one of the biggest challenges inside Hadoop, even though Hadoop has so much metadata, as Chung pointed out. Every single component that you see listed here, Pig, Spark, Hive, MapReduce, and so on, every single component maintains its own metadata repository. Some of these metadata repositories are searchable, some of them are not. None of them have consistent searching across the board. So some have SQL interfaces, some have a REST API, some have no interfaces. So show me the files that are older than 7 years. You can't do that easily inside HDFS. Show me the Hive tables that contain a column with the name, say, I'll use s_neighbor because that's in the example here. That's you need to do SQL or program with REST APIs. Let alone show me the files that are older than 7 years that are sensitive. Okay, so combining business and technical metadata, that just doesn't happen. You can't do that in Hadoop. So here, though, I'll show you a couple of examples of searching. So every single metadata repository is available on the left-hand side. If I'm interested in searching, say, HDFS, you can see HDFS files are popping up, created in a certain time frame, let's say in the past 90 days. Let's say I only want to see files. We can see a bunch of deleted things popping up. For every single entity that we collect information for, we bring in several dozen technical metadata attributes that you can automatically filter on. So let's say I don't want to see deleted files. I'll choose deleted and do not show deleted. You can see that underneath the hood, this is built on top of Solr. So all of the expressiveness that you get in Solr is available. And as I go through the policies, you'll see how that's useful. But as an end user, you don't need to worry about it. Okay? But you can define policies on anything you can refer to that spans both the business and technical realm of metadata. So this is an example. Any of these, we can jump over to Hue and find the data, look inside the details. That would trigger an audited event as well. Another quick example, if I wanted to find permissions, let's say HDFS files, and I want to see if anything has permission 777. Fortunately, nothing here, though if I remove the files, we see there's some directories. These are deleted, but I think there should be one that isn't. And to prove that to you, I'll just go to deleted. Oh, and we have a couple. Oh, there we go, yeah. Okay, so that's HDFS searching. What I'm gonna do now is quickly shift over to Hive searching because that's where I can show you metadata, lineage. Now, underneath the hood, everything I'm showing you here is automatically collected. One of the key things of looking at trust and visibility as two not necessarily opposing but complementary forces is that you need to be able to roll out these kind of governance capabilities without impacting your users. If you want to roll out, say, Impala or Hive or some other kind of capability to your end users, restricting them to just one subset of functionality can be extremely limiting, especially if that's the only way you can govern the capabilities. So Navigator is basically a turnkey solution, and you'll get all of these automatically. The only thing that you basically have to incorporate is you define the policies for classification of metadata and any metadata editing, business metadata, you would add as well. But everything else is automatic. So here, I'll just quickly show you Hive tables. Let's say we only want to see real estate tables. So this is some of the business metadata that we have here. Real estate. We have one table that pops up. And if I look inside sales data, you can see the lineage that's automatically collected. So Chung mentioned that this is probably the hardest part to figure out when you're in a regulated sector, reliably keeping track of the transformations that took place and how data is being used. Inside here, it's restricted to a couple of Hive and Impala queries. I'll go into more detail about it in a moment. But being able to see things like if we had scoop jobs, if we had MapReduce jobs, Pig jobs, anything that takes place will be viewed holistically. For the purpose of this demo, I have a simple kind of set of transformations that are restricted to Hive and Impala. But this shows us, and I'll zoom in a little bit. Whoops. We can see sales data is being used to generate these 4 tables. And column level lineage is automatically collected as well. Okay, so anyone who's regulated or in a regulated industry would understand that lineage without column level lineage is basically meaningless. It's necessary to know who's taking the credit card numbers versus who's taking the product codes from a particular system. Okay, so briefly on the left-hand side, I'll show you for sales data, the metadata that we can provide. So any of the tags, any data set, whether it's a table or column, we can capture all of that. We can put in named value pairs. And without going into much detail about this, I'll jump back to the searching and show you the policies you can define on top of all of this. Okay, so again, the point of this isn't a demo, it's just to give you a taste of an approach. Okay, so if we go back to searching here, remember I pointed out Hive Tables, or let's say a Hive field with the name, say, s_neighbor. We see all the fields, and if I wanted to create a policy on this, anytime something arrives with this name, I can create a policy, okay? And this is the policies part of the tab. You can see the Solar string that appears here. We can check out to make sure that it's valid. But what I'll do instead is show you a couple of policies that I've already defined. So the idea here is, as an administrator, how can you make sure that you're managing data as it comes in, that you're monitoring data on an ongoing basis, you're classifying it appropriately so your end users can use the business metadata that's useful for them to find the data sets they care about. All of those things that I mentioned are difficult to scale. So here's an example, archiving. Okay, files that are older than 7 years. Because we're on Solar, we get all the expressiveness of Solar. Anything that's over 7 years old in HDFS that hasn't been tagged as archival, we can go ahead and archive it. Anything that arrives in a particular directory, maybe we want to put in some tags, real estate, MLS, and sales, and then also have an expression for retention time frame, 7 years from today. Sensitive data, making sure that anything that's tagged as PII is also encrypted. And you know, it's funny, this is one that a bunch of customers have been asking for, and it's such a simple one. When you're dealing with sensitive data, how do you make sure that your end users are not deriving data sets and setting up permissions incorrectly? So if you have sensitive data that's protected and they derive a data set and that data set isn't protected with the right permissions, how can you manage that? This will automatically make sure that there's nothing with the wrong permissions in the data hub. Certainly these are some easy examples. You can be much more elaborate and sophisticated thanks to Solar, thanks to the combination of business and technical metadata. But these should give you a taste of the kind of policies that are really necessary, and whether you implement it here or find some other kind of mechanism to do this, these are the kind of things that stewards and curators really need to gain control of if you plan to ingest more and more data and keep up with the pace of growth of data, especially on the semi-structured and unstructured side. So that's it for the demo, and then I'll briefly jump back to the closing slides. So, you know, our view with when it comes to trust and visibility is that when it comes to all those building blocks, these are really the foundation of a much broader set of data management challenges that need to be addressed for any effective and productive Hadoop distribution, or deployment rather. And ultimately, you can see business metadata, technical metadata, lineage, policies, audit logs. These are the foundation of the data management strategy that we have at Cloudera that we're already executing on. So all the various stakeholders have basically care about data management from their own lens. Business analysts, as I mentioned, and data scientists, they need to find the data sets they care about. And with this governance foundation, we can do things like tell a user when they find a data set, who are the top users of this data set? What are the related data sets? That's thanks to analytics on top of auditing, analytics on top of lineage. What are the related data sets and how do I join? These are things that will either take an end user weeks to figure out, or they'll burden the administrator and be frustrated that you're not responding to them, or they just will abandon the analysis and they'll stick to their regular kind of analysis. So a drop in productivity, a drop in results. So that whole situation of how can you leverage this governance foundation to empower the business analysts, we have capabilities for. Another area that's unique for us is usage-driven model optimization. So again, these Hadoop administrators and database administrators are faced with the task of ingesting data and making sure that the tables are set up correctly, that the replication factors are set up correctly, Some of these tables may never be used. Some of these tables may be used way more frequently than they expected. Some of the tables may be joined with other tables on an extremely frequent basis, which could result in a lot of wasted cluster time, a lot of wasted end-user complexity. Why not just make recommendations and say, based on all of your historical activity, here's how you should set up your tables. And by the way, now it's time to repartition this Impala table. And this ongoing optimization of the environment that's built, again, on the foundation of real user activity. That as well is part of Cloudera Navigator, and it's through an acquisition of Explain that we purchased, I think, about in the past half year. Then, of course, compliance-ready governance and protection. This continues to be a strong area of focus. We have over 200 customers relying on Cloudera Navigator in production specifically for this reason. And I really would be remiss to say that that is not a really significant area of focus, and it continues to be. Anyone who deals with sensitive data, anyone who deals with any kind of regulation for how the data is being used, this has been an area that we've been focusing on for many, many years, and we continue to focus on this. And then finally, the active data management and lifecycle management. This is all about making the lives of the stewards and the curators easier and more scalable. And I think we spoke quite a bit about the policy management inside Navigator. So the final piece that I have here is to just talk about the fact, a common question when I speak with folks who are looking at Hadoop and evaluating it, you see all these other tools and you hear all these governance capabilities, and it sounds a lot like Informatica, or it sounds a lot like the InfoSphere family of products like Guardium or DataStage or QRadar and so on, or potentially Ab initio and all these. And a question that surfaces is, why do I need to worry about this in Hadoop if all of these other products are handling this? And the reality is, these products are complementary. Okay, so if you look at any of those broader framework governance tools, they effectively don't have any insight into Hadoop. Okay, now you can poke holes in what I said there because certain areas do have insight, certain don't, but across the board they don't have the necessary complete coverage that you would need to properly govern your environment. So, so we already have integrations with basically all the leading players there. So out-of-the-box integration with Informatica, out-of-the-box with IBM InfoSphere, and so on. And what we do is provide all the insight into Hadoop from an auditing perspective, from a lineage perspective, from a metadata perspective, and so on. And then they provide the holistic view. So if you're interested in looking at everything from the view of Informatica, you'll have all of your Hadoop information right in there. And this is not restricted to those Informatica workflows that are invoked on top of Hadoop on MapReduce. It's all the work that's running inside Hadoop. So if you have an organization that relies on Informatica, you can continue to, but you can also bring all your Hadoop data into there. We can certainly talk more about this at our booth. One final point here is that lineage as well, there can be a lot of abstractions to lineage. So looking at a transformation from the perspective of MapReduce or the perspective of Hive or Pig running on top of MapReduce, or potentially the partner product that triggers that workflow. So Trifacta is one of our partners, and they run a lot of Pig scripts underneath the hood. We're working with them to augment our lineage and a number of our partners so that you can look at lineage from a holistic view from the technology that triggered the workflow and then drill down more deeply. And I think that's actually at the Trifacta booth for showing. Yes? Okay. Oh, okay, Sean's here. Okay, so with that, I think the final thing is please stop by our booth, or Trifacta's booth, if you have any more questions. I hope this has been helpful, and certainly we can stick around for a bit if there are any questions. Okay, thank you.